Hi, I don't need help. I just want to tell you happy birthday.
Thank you.
You're welcome. I'm fixing to go to the little teacher walkout thing at McDonald's. But then I was like, wait, because I was about to email you. But then I was like, wait, she's on that live stream. I can just tell her happy birthday there.
Thank you.
You're welcome.
All right.
Bye.
Bye. I will.
Oh, hello. I don't know how this works.
Can you see what's on my screen?
Is it just like a blank calculus thing?
Dang it. Why can you
Uh,
not see what's in mean? You don't see anything?
It's just like you're on calculus 7 through 18. No, oh wait. Okay, there we go. Okay, you're on MC review 2, right?
Yeah. Do you see the actual questions?
Yeah. Now I can.
Okay, good. How's it going?
I'm enjoying spring break.
Oh gosh, yeah.
I've done calculus. I don't know if I've done enough calculus, but I've done some.
Yay. Well, that's good. That's better than others.
I just need help on the very last one, on number 2. That's the only one I don't know what to do.
Okay.
I'm just like confused on what it's asking me.
Well, it's telling you that the thing is continuous.
Uh-huh.
So this is really a piecewise function.
Oh, great. Okay.
Well, the way it's written, so I'll write it a little different. Oh gosh, sorry. I'll just write and mute myself.
You're fine. Oh, okay, I get it.
Okay, maybe he's done barking. Okay, so it wants you to make it continuous.
Yeah.
Right, so like the 3 things were plug it in and you get a number.
Yep.
Right, and you clearly do. They told you you get K. And then the second part was the limit as you approach 0.
Uh-huh.
Which is the left and the right. So that's got to be this top part because that's the left and the right of 0. But limits, you have to reduce it first before you plug in.
Uh-huh.
So if you reduce that, what do you get?
If you reduce it. You get 0, don't you?
No, like if you simplify that top thing.
You pull out
I factored it out over on the bottom left.
and then okay, see, wait, you get okay, now I'm looking at you. You get x minus 1 over 2.
All right. So that's what you would plug in 0 to.
Okay. You get negative 1/2.
Right. And then for continuity, the definition of continuity said this answer and this answer have to be the same answer.
Okay. Gotcha. So I don't know if like you went over this yesterday, but I was at a tournament. Are we doing this walk Sunday still?
No.
No. Okay.
There's no way I can get all of you guys and make it required. I'm gonna have to move things around.
Okay. I was wondering.
You have anything from 3?
Let me get that. Yeah. Probably.
I do.
Wait a minute. There's another person. Hi, Sammy.
Hi. Will you do number 4 on 3?
Sure.
How are you?
I'm good. How are you?
Good.
All right. Are you ready?
Yes, ma'am.
Okay. So it's up to you how you want to do that, but I would probably use log rules to make my life easier. And then come back and do the algebra because the way it's written right now, you've got a product rule in there with a exponent.
Mm-hmm.
So I would probably rewrite this guy using log rules that says if two things are multiplied in there, you can separate them and add them.
Okay.
And then because the second one has a power of 1/2, I can bring it out front.
Okay.
So that would be what I was going to take the derivative of, which is a little bit easier derivative. It's going to be a little harder to get the algebra back, but that's what we're going to do. All right, so what's the derivative of the first part?
1 second. I'm losing my stuff. How does this work? Like, do you see me or something?
I can if I scroll back, but right now, if I need to show you this, then I can only see what's on my screen and hear you.
Okay.
But I can click on you, and right now you're just a picture of you and your boyfriend.
Ah, okay.
Because you'd have to like share your camera with me. So if you want me to look at any work, you have to like present your camera, and then are you on your phone or a computer?
Phone.
Then you'd have to like aim the camera toward what you want. So I don't know how it works for you. Like, can you just see my screen?
Yeah, I can see like just your work screen.
Okay. So are you ready or?
Yeah, I just can't find mine. 1 second.
What is this?
Okay, I'm ready. Okay, so the derivative of the first part is 1 over x, right?
Yep.
Okay, so 1 over x. And then we do the derivative of the inside of the
What
x
do we do
squared
that
plus
1/2? Oh wait, are you talking about the derivative still in that first part?
No,
Oh, okay. So what do you do with that 1/2 that's sitting out front?
leave it there.
Okay. So then we would have
2x times 2x over x.
Okay, no, you got to do whenever you do natural, you do 1 over whatever's inside.
So over x squared plus 1.
Right. So I'll do it in pieces because I thought you were going to. Oh gosh, sorry.
It's okay.
Kai, quit. All right, so that would be your derivative.
Uh-huh.
Now you got to simplify and match it to one of the answers.
Okay, so we can do
So on that second part, what's the simplification?
well, you put the 2x put the 2x in the 1/2, multiply that and x, we can put an x on top of the x squared plus 1.
Right.
Okay, so it'd be 1 over x plus x over x squared plus 1.
Right.
And then we need to
go ahead.
We need to do a common denominator.
Right.
Can we just multiply by x plus 1?
Well, the first term you'd have to multiply by the x squared plus 1.
Mm-hmm.
And the second one you'd have to multiply by the x.
Yeah. X plus 1. Okay. 1 x over x cubed. 1 plus x over x cubed plus 1. Are you leaving the...
So if you look at those answer choices, they didn't multiply the things together on the bottom.
Mm-hmm.
You probably don't need to make it x cubed. I mean, you could,
okay.
but most times they factor.
So it's not this one. Okay, so it's D.
Yeah, Will?
What's f to the IV on 10? What does that mean?
It's the fourth derivative.
The fourth derivative?
Oh my
yeah.
Oh, okay.
It's not that hard. It's a relatively easy function. You just keep going.
Okay.
I'm going to do that then real fast. first.
Are you still okay?
Oh, that one was easy. Okay. Will you go back to multiple choice review 2?
Yeah.
Okay, on number 4. Basically, on these, I'm plugging in, like on 2, I'm plugging in 0.
You plug in limits, or you plug it into the most reduced form.
Right.
But you got to be aware some limits are horizontal asymptotes. They're really asking that.
Uh-huh.
And then reduced form, and then you got to make sure that you understand L'Hopital's rule.
Oh, yeah, I remember that.
Okay, so on 2, you should have reduced first, and it should have been really easy.
Mm-hmm.
What did you get on 2?
I haven't done 2, but I'm looking at it. Okay, so the most reduced form, isn't that just 1?
Yes.
Okay. So the answer is 1.
Yes.
Okay, that was easy.
Okay, so 4, you can't reduce that because
Mhm.
X is the angle there.
Right.
And that's not a horizontal asymptote. So you just have to plug
It's
in.
not infinity. So you just plug in, 0 on the bottom. Anything 0 on the bottom is 0, so 0.
No.
No?
Anything 0 on the bottom is not 0.
I mean, undefined.
Right, but you got to make sure what the top is first.
Okay. Where tangent is 0. I haven't done math in a long time.
That's not great.
Well, where do we get that? Okay, I see.
Is pi?
No. What? No.
What tangent is 0?
No. The tangent of 0. So of 0 pi. So that's the sine of 0 over the cosine of 0.
Right. Oh, okay.
So the sine of 0 is?
The sine of 0, pi is 1.
No.
I mean 0. I'm a 0.
Yes.
Sorry, y, x, sorry.
So you get
0.
yes.
Okay.
So that's an issue. Like normally, yes, if you get 0 on the bottom, it's undefined and you move along. But if you ever get 0 over 0, that is not undefined and that's not 0, that's indeterminate.
Mm-hmm.
And that's where you have to do L'Hopital's rule, which says go back to this first one and take the derivative of the top and the derivative of the bottom and do the exact same thing again.
Yeah.
So the derivative of the top, it's not a quotient rule. The derivative of the top is?
Secant squared.
And the derivative of the bottom is?
0.
No.
Well, 1, sorry.
Right.
1 over secant.
All right, so then you're going to try again, and now you should probably be able to tell that, hey, you're not going to end up with that 0 on the bottom anymore. So your job is just to find out what's the secant of 0 and then square it.
Okay.
William, you have more things on 3?
Did you say 3?
Yeah, review 3 or review 2. I don't care, whatever you want to do.
Okay, since you're on 2, 6, I know like it exists, but isn't it continuous too?
You just have to go through those same 3 things. So it's all about 1. Did you get f of 1?
Uh-huh.
Was
2. Or wait, no, 4, sorry. 4. And then you.
And then you have to take the limit as you approach 1, which would be put into
the x squared minus 1.
Yeah, but you've got to reduce that first.
And then you just have x plus 1 over 1.
So you get
2.
Right, and then the third thing says to be continuous.
Oh, to be continuous, they have to equal each other.
They have to equal each other.
Okay, so it's just b. Okay.
Whoa.
Wait, they don't equal.
Right, but Roman numeral 1 says, does the limit exist?
Okay, yeah.
Roman numeral 2 says, does f of 1 exist?
Oh, it's 1 and 2. Okay.
And then 3 is continuous.
So on 14 on C, or review 3.
Yeah.
So C, we take. So you would have to do your secant, your tan, not your secant, yeah.
Yeah.
Minus 6, and you have to do top minus bottom. You can.
What are you doing top minus bottom? What are you talking about?
For your the M secant, right? You do the
Yeah, what do you mean top minus bottom?
like your function on top minus you plug in the values and then over so it'd be like f of 2 minus f of 0 over 2 minus 0.
Oh, yeah. Okay, gotcha.
So your top is 0.
Yeah. So back when we learned Rolle's theorem is the special version of mean value theorem that says this guy's always going to come out as 0.
Okay. Yeah. I see that on the front page now.
But you still have to do the other part regardless.
Yeah, you set them equal or you get 1, right?
Set what equal?
Huh?
Set what equal?
The your derivative of your
So you
function
6x minus 6?
equals 0.
Yeah.
You get 1.
Yeah.
You just you have this.
Sammy, was there anything else you wanted to?
I might in a second. I'm reading over all the notes and stuff again.
Okay.
Is number 1 E?
On 3 or 2?
3, sorry.
I don't believe so. Where'd you
Right.
get?
I'm sorry.
How'd you get E?
I just did a chain rule for both of them. Or do you have to?
Also do a
Chain and
product
product.
rule?
You have to do both. Okay.
Yeah. Oh, lordy.
Okay.
And then-
So this is like the ones that we did a while ago where we had the chain of the product, and then you're going to want to factor out big chunks of things.
Mhm.
Remember, like the bracket stuff?
Yeah.
So they're not written like this, but you'll see like 4x plus 1s and 1 minus x's.
The brackets.
Mhm.
Right,
Oh,
on most of them, like those have been factored out.
Mhm.
And then what would be left would be, all right, what happens after you factor that?
What do you mean? What happens after you factor?
Like what would be left out? So like if you had, I'm just making, well, we can just go ahead and do it together because I don't want to write something wrong. All right, so if you did the derivative of that first one,
you do the 2, bring the 2, and then leave the inside, multiply by that. So 4, so it'd be 8 on the outside.
and then you still have the original second.
Right.
Uh-huh.
And then we do plus.
The right side. So it's 3, 1 minus x, negative 1.
Yeah.
All right. And then we've got these two terms, and instead of like foiling everything out and trying to add combined like terms, we can take out things that are identical in both of them.
Because they're exponent.
All right. So like what could you take out of both terms?
We can take out 1, 4x plus 1, and 2, 1 minus x.
Yeah.
All right. So if
we
you do
put them-
that, that's gone. That's down. That's down to 1. Those are all gone, right?
Yeah.
Mhm.
So then what would be left in the brackets that I was rambling about was, all right, all the stuff that was left over that you didn't pull out.
Right.
So you would have in that first term, you have a 2, a 4, and a 1 minus x.
2, 4, so 8. 1 minus x
Plus 8.
plus.
All right. And then the second one, you have a 3, a negative 1, and a 4x plus 1.
So negative 3, 4x plus 1. Parentheses 4.
All right. And then that's what you can do a little bit of like distributing and arithmetic here.
So you can do 8 minus x plus negative 12 x minus 3. You combine 5 minus 20x. So it's
Typo.
it's 8 plus negative 1 is 5. You only took 1 for x though.
Yeah, I think I might have a typo.
It looks like it would be a, but it's
Isn't
it
it?
should only be 1 for x plus 1.
Yeah, no, that's what I'm saying. Like you guys have the
Oh.
squared on yours as well.
Yes.
Yeah.
Yeah, that shouldn't be squared. It does come out as 5 minus 20x, right?
Yes,
That's
ma'am.
what I got.
Because you're adding.
Yeah, that's a typo on my thing on A.
Okay, so it should be 4x plus 1 to the first.
Yeah.
Okay, so it's a. So then 2 is y. This is just chain.
Hang on 1 second. I gotta go let my dog out.
Okay.
Okay.
So funny. Did you get B on 2?
Me?
Mm-hmm.
Yeah, that's what I got.
Yeah, that's what I'm looking at right now. Oh, I hate E. Oh my gosh, I hate E to X.
Why?
Because I don't like the way it looks.
Yeah.
It's intimidating.
It's not hard, but it just like
It
it
looks
just
gross.
They're so easy. You just write the same thing down twice. Or like same thing down again.
yeah, pretty much.
So when we come back to school eventually, are we gonna take like our chart quiz and stuff?
I have no thoughts. Like I wanted to stay as much on schedule as possible, but we're probably gonna end up skipping a chart quiz.
Yeah. Have you been up there at all?
I have not. I'm supposed to go up there today to grab something because I got to drive to Kansas tonight.
Ooh.
Gross.
Gross.
Oh my. Can we do back to number 2?
Back to what?
Sorry, I was reading your mind.
Oh, that's for Kim, huh?
Yeah, review 2. Again, on number 5. I'm looking at it and I'm like, what?
I'm like, what?
That's what I'm doing.
What am I asking about?
Horizontal asymptote.
Right. What's the horizontal asymptote?
What's a horizontal asymptote?
No, I just drew the graph. What's the horizontal asymptote?
Of that little squiggly thing.
Yeah, what's the horizontal asymptote of this thing?
Well, horizontal asymptote is where your line is not on the line, but it's like skirting across it.
So
is it underneath or on top of it?
What's the horizontal asymptote in that picture?
Oh, there's some numbers.
It doesn't. It doesn't matter from what your description that you just said.
I said either on the bottom of it or the top of it.
It's not an either or situation. A horizontal asymptote is one number that x approaches infinity. So as you go this way, what one number is it getting closer and closer to?
Yeah.
What one number is it getting closer and closer to?
Infinity.
Infinity is up here.
Oh.
For sine, this is 1 and this is -1.
Right.
What one number is it getting closer and closer to?
Stop.
I know, Sammy, I'm trying to make a point. What one
pi.
number?
Something with pi.
No. You're overthinking it.
I am. But
What one number am I getting closer and closer to? What?
Stop drawing squigglies. Well, on the bottom it's -1, on the top it's 1. But that's... So is it -1 and 1?
So if I had this graph and I asked you what the horizontal asymptote was.
0.
Oh, so no problem?
Right.
Okay. So...
-1 and +1.
It cannot be two answers. You must have one answer.
-1?
You are way overthinking it.
I'm confused.
Look at your answer choices.
Yes, ma'am. Is it E? 1 or -1?
It must have. Must have one answer.
Then why? It literally. The answer is 2 answers.
That's
not for one of them.
That's not possible. Look at your five answer choices.
Huh. Is it C? What is it? What is that big word even? Like, what is that?
Oscillates means goes between.
Oh, so it's that one.
Okay. Why are we not getting this? It must be one answer or there is no horizontal asymptote.
Okay, I don't think there is.
There is not.
It's not really skirting across anything.
Right.
So there is none.
Right.
Does not exist.
Yes.
The limit does not exist. Okay.
Come on, Lindsay.
Who's Lindsay? Oh, Lindsay Lohan. I was like, your dog's name's Lindsay?
That's a great learning experience.
Thank you.
There's a lot of squigglies.
Yeah, I picked oscillates, and then Paul yelled at me and said it could only be one thing. And I said, okay. So
Okay, well, if it can only be one thing, it's rude to have two answer choices that are more than one thing.
yeah.
Just
It's not rude. It's saying, oh, well, it can't be those.
I guess.
Yeah, see in your notes on the front page, I don't think it says it can only be one thing.
The horizontal asymptote?
Hold on. Compare the highest exponent of the numerator with it never says it has to be one number.
Well, the numerator exponent is, I guess, larger than the denominator because there is none.
Mm-hmm.
And there's
Oh. Oh, you could have said, okay, that would have been easier. On it's 3, number 12, I feel like it should be way easier than what I'm doing.
hold on. Kai scratched, and when Kai scratches on the door, I have to go get him.
Okay.
Okay, go ahead. Sorry.
Me?
Yeah.
Oh. On 12 for number 12 on review 3. I feel like it's way easier than what I'm trying to do.
What are you trying to do?
Because
Wouldn't you just?
oh yeah, I mean like you compose of it.
You put that square root of x into f of x, right?
X. Yeah.
So you get 1
over x plus 1.
Plus 1.
and then I want you to take the derivative.
That. Yeah.
Can I just put that to the negative first so I don't have to?
Yep.
Negative 1, x plus 1 to the negative second times 1. So it's d.
D?
No, you did it wrong. You did it wrong, I think, right?
Oh, I mean b.
Okay, I was like, you said the perfect answer.
Sorry. Wait, wouldn't that be?
Yeah.
Oh no, that would be.
Wait, why did they move it back to the bottom? That's weird.
Except that's not that's positive. D
Right,
is
D
positive.
has a positive one, and B has the negative one.
Yeah, that's I saw that and I was like, they're gonna move it back to the bottom, and then they didn't. I wasn't even paying attention to if it's negative or positive. The point moves on a curve. Wait. For 9? I think I'm overthinking it as well.
Why?
Because, like, it's asking for y double prime.
Mm-hmm.
Point moves on a curve. It looks like implicit just by looking
Yeah.
at it. Is that what it is?
Yep.
And then you just do it. You do the second.
Right.
Right.
I mean, you could probably solve for y in this one, but you have to incorporate the positive and negative.
Yeah.
I think it's actually probably easier to do implicit here.
Okay, so I'm doing.
So what would your derivative be?
2x plus 2y dy over dx.
Yeah.
Equals
0.
0. So you probably want to solve that for dy dx.
That's what I did, yeah.
dy over, oh, gross, 1. I have to take out dy over dx first. Where does it subtract? Over 2y, dy over dx equals negative 2x over 2y.
Yep, and I'd get rid of the 2's.
Negative x over y.
All right. Did you
And
take
then
the
do
second derivative?
second derivative.
Did you
D
do
is it? It's
quotient?
d squared y over dx squared, right?
Or you can call it y double prime, whatever.
Right. I was just curious.
Yeah.
What it is. So that's negative x over y. First part negative 1y plus.
Why'd you do plus?
I mean subtract. Sorry, it's
I just didn't know because you're gonna end up.
It's not now.
Okay, so then the derivative of the y would be,
dy over dx.
and then put it next to
Negative x. Oh, I don't like this. This is getting messy. All over x squared. Can we just plug in? No.
right. So you don't have to simplify it at all. You know that x is 0 and y is 5, and then the other thing you're going to need to know is dy dx.
Mm-hmm.
But you know that dy dx is negative x over y.
Uh-huh.
So dy dx has to be
negative 0 over 5.
So 0?
Yeah.
Right? So then that entire blob goes away.
0, yeah. All that thing. So it's just negative y over y squared.
Yes.
So negative 5 over 25 is negative 5. C.
No.
No,
Really?
negative 1/5. I think so.
Okay. This is what's going to happen on multiple choice. You guys will do implicit twice, plug everything in, and then be like, yes, nailed it.
I feel attacked.
No, that's what you'll do on multiple choice. That's why we are much better on first one.
True. I wonder if I can use the school phone.
All right. What else? Because I got 4 minutes before chemistry gets.
Oh wow, you got this down. You do this like all day?
No, I have 3 things. I'm going to do rates free response from 1 to 2 for calc, and then I've got 11 to 12 for chem.
Wait, what'd you say?
1 to 2?
From 1 to 2 today. I think that's what I put on the remind.
Okay, you did. Okay, I'm thinking of yesterday's. Okay.
I'm going to go over the rates free response.
Okay.
I would have done it later, but I have to drive to Kansas tonight.
Okay.
Anything else?
Wait. What is it saying on 8? Or I mean, all of those questions. It's just saying.
So 1 through 8.
7, 8.
Back in the directions, 1 through 8, you were just supposed to find the derivative.
Oh, right. Okay. So that would be. These are implicit. Oh, this is trash. 6 has an L in it. I don't like LNs or E's. I just don't like.
And heads up on like things like 8. If you remember when we talked about it, like that's obviously looks like implicit.
Mm-hmm.
However many y's you have in the original problem should be how many dy dx's you have.
Right.
And however many dy dx's you have, that's how you're going to have to factor that out. So you're going to, if you have 2 dy dx's, you're going to have 2 terms with dy dx's, and you're going to end up dividing by that. So like, just to show you, since we did 9, we had 1 y, we had 1 dy dx, and you had 1 term in the denominator, right?
Mm-hmm.
You don't have 2 y's?
Not on number 9. How many like times you physically wrote y? Because that every y you hit, you're going to have a dy dx from, right?
Mm-hmm.
Yeah.
So like if you're looking at number 8, there are 2 y's here. You're going to have 2 dy dx's. You should end up having to divide by 2 things.
Okay.
Which can help you eliminate some answers.
Oh.
Like
because
you don't have the right number of things to divide by.
Yeah.
Right.
Should be gone.
Those you probably shouldn't select. But it still could be A, B, or E. And then if you do look at this, A and B are very similar. They're just in signs.
Mm-hmm.
So for multiple choice tips, you might want to be like, hey, that I got to pay attention to my signs, but I probably should have a 3x and a y and a 5y and an x.
Yeah.
All right, you got 1 minute. Anything else? for those.
You just stay on this one.
I'm gonna because I couldn't get another link. So
Okay, so I'm just gonna stay here.
I guess I'll leave because it's not my time.
Well, is there anything else? I've got 1 minute for you. Is there anything else you want to talk about?
I don't know if we can do anything in 1 minute, but I think I'm good.
Okay, I'll be back for rates later if you need anything for rates. Oh, are you two okay if I put this unlisted on my channel, whatever, so that other people can get help or no?
Yes.
What do you mean? Oh,
Like-
like
I was going to save this and upload it to YouTube, so if they couldn't make it during this time, they could still watch the question.
oh yeah.
Yeah, because I'm gonna go back and watch what you did with Will before I got here.
Okay.
Yeah. I think she would do like 1 or 2 problems, but yeah.
Yeah. Okay.
All right. Y'all have
Bye,
fun with
Will.
Bye,
All right.
Will. All right. Chemistry.
I wasn't paying any attention to the calculus remind and stuff, and so I didn't even see that y'all were doing it, and so I was working on chemistry the entire time you were like that 20 minutes that I wasn't on calc.
Oh, it's fine. No one was there. Will showed up like 2 minutes before you did.
Oh, okay.
All right, let's see if those chemistry hoodlums come back. Luke?
Yeah, Luke said he was coming.
What?
What?
Hey,
He
Luke.
got a haircut.
You got a haircut?
He looks great too. Wait, can he not? Oh, he has his mic off.
He has his mic and his camera off. Come on, Luke.
He came off the top.
I don't have a webcam on my computer.
Oh,
Oh, hi.
you want to see your haircut? Hey.
Oh, she told you about that already?
Yes.
That was quick.
I haven't been okay since I was born. Target!
Hello. Kai says hello.
Hello! Wait. Yeah. Oh.
The dog.
There's a dog.
Oh, shit. We got a scoop.
Kai, quit it. I just want to clean.
Wait, where are you guys?
Ow. Okay.
Yeah.
Okay. Wait, I
Yeah.
All right. What do you guys want to go over?
everything.
All of it.
I looked at the free response for Stoic, and all 3 of them we already worked in free response.
Yeah,
She
we
told
did.
us that.
That's my dog.
Oh my god. Who's dog?
Calculus away.
All right. So you said free response, but then you said we worked all of them. So what do you want to do?
Have
Multiple
some-
choice. You know what?
Oh, anything you guys want me to work?
Are we doing multiple choice or free response right now?
Whatever.
Anything you guys want from this packet?
We do multiple choice.
Yeah, I say multiple choice.
Okay. Well, so pick some. Like
Okay. 2. Yeah.
2.
Yeah.
Okay.
2. How about 2?
These are all winners. These are more like helping you practice different things. All right. So we've got an empirical formula, CH2, gives us a density, a temperature, pressure, wants to know what the formula is going to be. So what can you find out of DT and P?
Molar mass.
Oh,
Molar
yeah.
mass.
Dirt.
Dirt over B. Oh my gosh, you can't hear much now.
All right, so you just have to be careful about your units. So we have 1.88, 0.0821,
That's per liter.
273, and 1.
Mm-hmm.
Oh, no, you guys have to use separate piece of paper. I crammed the smallest space as I possibly could. So if you were doing this without a calculator, your multiple choice, knowing what that blob is equal to,
two.
22.4
Times
Yeah.
2, 44.
all right, right. So if you multiply that by 2, you get 44.8, but you have to know that it's going to be
Little bit.
a little bit lower than that.
Lower, yeah, because we took 2.
All right, so then when you're trying to find out which one these are, the only thing different is their molar masses.
Mm-hmm.
Don't take the time to add up like 1.008. Like if I were going through this, I would say CH2 weighed 14 because I'd have a 12 and a 2.
Mm-hmm.
And I'd have 2 12s and 4 1s. And then I have 3 12s and 6 1s. Is someone at school?
I'm in my mom's classroom.
Who's in class?
Oh. So this one's what, 42?
Yeah.
And then this one's 56.
I
And
say
this one's
C.
70.
70, yeah. So C. I say C.
Sorry.
The mass.
Okay. Oh, I got C, but I ran out of light.
Is that like average?
Can I get a piece? No.
Oh, God.
Okay. So like 3. Number 5.
Simplest. Yeah.
Oh, it broke.
All right. Number 5. So simplest formula, you're looking for
No. Empirical. Okay.
empirical again. And so an oxide of nitrogen tells you that you have oxygen and nitrogen in there.
Mm-hmm.
And we have 36.8% nitrogen, which you can tell, you can call that grams. You can say I have 100 grams.
Yeah. So
And then you would
it's
have
100.
63.2 grams of oxygen. Is that right?
Yeah.
Yeah.
But you probably don't want to do that with multiple choice, like 36.8 and 63.2. You probably want to call that like 37, 63.
Oh, okay.
Okay, now I think some of these were older and they were before they took the calculator away from you. So these numbers aren't as pretty as they would be now.
Oh, okay.
So you could try to do a rough estimate on this, but you would still try to get grams of each and then convert to moles.
Okay.
And so someone would probably have to do this with a calculator, but if I were estimating, I would say what? 2.5? And roughly 4.
I don't have any razor.
So someone's probably going to have to do calculator work on that one, get them a little bit better.
Okay. I got 2.63 for the first one. And then,
That should be pretty close to 4.
yeah, it's 3.98.
All right, and then you would have to do what? What's the last thing?
Divide by the smallest.
All right, so you would have to take the 4 divided by the 2.63. So
I got 1.5.
Notice
1.5, yeah.
E, right?
Yeah, so N is 1, O is 1.5, so N2O3.
N would be 1. How is it?
Right?
Yeah.
No,
And
never
then
mind.
N2O3.
Because it can't be the 0.5. Okay.
Okay, but if you had to do this, if they were a jerk and you had to do this without a calculator, if you're looking at these numbers right here, you can see that O is going to be.
Oh, sorry, I have minute music.
So you're gonna have more O than N, so it's not A or B. And then O is not quite double N. And E is more than double N. Who is celebrating?
I said I submitted music at school. Sorry.
Oh, that's the okay.
Yeah, sorry.
You could mute yourself, crazy.
I thought you wanted to hear it.
Oh, okay. Apparently Kylie does.
Okay, one second. I forget.
That's the only joy I get from doing this packet.
What?
See, right? Yeah. Okay. Did you do 8 right?
Yep.
Then you can talk to me about 3.
Okay.
Did you do 6?
Yeah.
Okay, you can talk me through that one too.
Oh, I don't. Yeah, I need help.
Did anyone get number 9?
9. 9's really tough.
9 is.
Like, it's not hard math, but it's really tough to understand at the first. So we can work 9 if you want.
Oh.
Yeah, I didn't know where to start on number 9.
Well, that's.
Okay, so they're telling you that Xe, xenon, and fluorine are going to be mixed, and you're going to make something that's a mixture of them, but you don't know what the product is, so you're not going to be able to balance it. But they did start giving you initials.
Yeah.
And then after something's happened, so it's not quite equilibrium, but I would set it up like an ice diagram.
Okay.
Because it will help you, I think. So they said initial of F2 is 8, and initial of xenon is 1.7. And then it says all of the xenon gas reacted. So xenon's got to go down to 0. And you're definitely going to subtract something here. And if you look at all the formulas, xenon is clearly going to be a 1, like in front of the balancing. There's only one xenon, but there's different numbers of fluorine.
Okay.
So if you lost all the xenon, and then it says when all the xenon gases reacted, the pressure of unreacted F2 is 4.6. So there's 4.6 left. And that means you lost 3.4. Does that make sense?
Uh-huh.
So if you lost 3.4 at the same time that Xe lost 1.7, you should see a relationship between the two of those. Thinking about like an ice diagram.
Yeah.
3.4 is twice 1.7.
Oh my gosh.
So that has to be minus 2x, which would tell you that this guy is a 2. If you think about it from an equilibrium standpoint.
Okay.
We just got to guess on this one. How much can I hear?
Okay, I can hear you.
Okay.
You can mute your microphone if you want. You can leave it on. It's fine. But you don't have to set it up like ice here. The idea is understanding that the 1.7 went away, and at that same point that 1.7 went away,
The
only
3.4.
3.4 went away for the other guy. So there's a 1 to 2 relationship, the 1.7 to 3.4. There's a 1 to 2 relationship between the xenon and the
Okay.
F2.
Okay.
Where's the 3.4 coming from?
Oh.
Is it something?
Good question. I don't
Right
know.
here. The initial
Oh,
pressure
1.7.
and the pressure and unreacted.
Okay, so 4.7.
Oh, okay.
Shut up!
Oh.
Someone have birds?
Yeah. It
We're
says
outside.
Oh.
Maybe we should mute our microphone for the.
Sorry. Did you do 11? Number?
Wait, but
Did you
9 doesn't have a 1-2 answer.
We tried.
It's a 1 to 2 relationship between Xe and F2.
Oh.
Oh.
That means there's got to be 4 Fs.
and because of balancing.
Oh.
Okay. How many?
Did someone say they wanted 11?
20.
Yeah.
Please do 11.
11? And then I heard 20?
We can do both.
Yeah, we can do both. And then if you guys don't want to, if you have your microphone muted or whatever, and you don't want to like speak out in the group, you can put something over in the chat if you want to like me to work a particular problem. I can see that. I can take requests that way. So simplest formula.
Empirical formula.
That's empirical formula again.
Mm-hmm.
And then we're doing an oxide of element X. So we're going to have X and O's. And this is very similar to question 6, I think. It says 24% oxygen.
Mm-hmm.
So we have 24 grams of oxygen, and then you have to figure out what the rest is. Well, that happens to be 76% of X.
And it says the molar mass is 76.
Right. X is 76, so they kept that really easy.
So it's 1.
Okay, so that one comes out as 1 mole of X, but you have to be able to do this. This is definitely one that they'll put on the AP test. 24 over 16, you should be able to reduce to 3 over 2. Divide them by 8, or 1.5. Whether you're a fraction or a decimal person.
Oh, okay.
And then you have to divide by the smallest, which is 1.
Mm-hmm.
So you get X1, O 1.5.
So X2O3. So whenever it says percent or whatever, we should just say that that's our grams.
Assume that you have 100 and then figure out yes, because 100 works really well with percents.
Okay.
Okay, I thought I heard someone say 20.
Yeah. Density of an number.
Okay, so this is D,
D.
T, this is T.
How you put this on mute?
Oh, this one's just plugging in, right?
This would be dirt over P.
Yes, ma'am. So you'd have to do this without a calculator.
I think this was developed before they took that away, but we're going to try to estimate.
Okay, so 4.2 times. Yeah, you already wrote that down.
So
400.
if I were you, if I had to estimate, I would call R 0.1
Mm-hmm.
and know that I made that
Too big, so it's going to be
too big.
too big.
So we have 4.2 times 0.1 times 400 over 3, and it depends on how you want to get that. You can do 4.2 times 40 over 3.
It's going to be 0.42 times 4. Oh, okay.
That's fine. You have to put that 0.1 with somebody.
Right.
And then I would get roughly around 160 with 40 and 4. And then 160 divided by 3 is going to be a little over 50.
Yeah.
So,
but it's too big, so it would be B.
So if you actually type that, if you went back in and typed this into your calculator, see what you would actually get, because I think this was designed before they took away.
Okay, I'm gonna do it.
See if you get B.
I got 45.97, yeah.
Okay. 27. Can you do 27?
27.
We can hear you.
Oh, yes, I can do 27.
But will she know? It's just the word mole. However you say it.
They took molar is something that's kind of like molarity, but a little bit different. And they
I thought it was a typo.
Off of the AP test.
I thought it was a typo too.
Wait, what is it?
She took it off.
That wasn't a typo. There's big M is for molarity. That's short for molar, or molar is short for that.
Mm-hmm.
And there's something called molality.
Oh, yeah, I remember you saying
Oh,
that.
I remember you talking about.
They took that off of the AP test.
So wait, this question we're not doing.
You do not have to. You do need to know what mole fraction is.
Right.
That is part over the whole,
Mm-hmm.
but you don't have to know what molal means. If you wanted to work it, I would have to. It means 4.6 moles of C2H5OH and 1 kilogram of water. That's what that means.
Okay.
So for mole fraction, what you would have to do, like you already have the moles of the part.
Right.
And you would have to know the moles of the whole, so you would have to convert this to moles.
Oh.
Okay. So you would have 1,000 grams.
1,000 grams over 118.
And so this was again before they take the calculator off, because clearly you can see those are nightmarish decimals.
Yeah.
And so this one, 1,000.
Oh, I got 55.506.
Okay. So then the mole fraction would be the part that they asked about.
4.6 over
the whole.
Yeah.
Which would be combined, which is roughly around 60, right?
Oh, wait. You do 4.6 divided by...
No, you do
divided by 55.5 plus 4.6.
Yes.
Right.
And you get B, but so you definitely need to know how to do mole fraction. You just don't know how to have to know what molal means. They would give you more of this instead.
Okay.
Can we do 30?
Okay, so again, my bad. It's molality again. And it's actually to go backwards.
So like that won't be on the multiple choice.
No. I have all my stuff. This is just old stuff that I've had for years before they changed it in like 2014.
Okay, I didn't even notice it said molality until right now. So I thought it was a typo again.
So yeah, no. So they're like that when they say the mole fraction of toluene, they're telling you 0.1 moles of the toluene over. You'd have 0.1 moles of toluene plus whatever moles of benzene.
Okay.
No, sorry, never mind. That they whatever your moles. This is telling you this comes out as 0.1.
Oh, it's like X and X. Okay.
And then you'd have to figure out what the molality is. So.
Okay.
But don't worry about that.
Okay.
Don't do that one.
And with molality, they've taken that off in the last couple of years. And I didn't teach you molality.
Can we do 28?
28.
28.
Oh
yeah.
Wait.
So 28 tells you that you've got aluminum metal added to hydrochloric acid, and then you're going to have hydrogen gas produced. But at that point, I would probably write myself a chemical reaction because they keep talking about.
I did that and then I got stuck.
All right, so aluminum metal and hydrochloric acid, they're making hydrogen gas. They clearly have to make another product.
I did AOCl3.
Perfect.
Yay! That's where I went. Oh, dang it.
Okay, and then you're going to have to balance this mess.
2, 6, 2, 3 is what I did. I don't know if that's right, but that's what I did.
I had it.
Well, that would.
Yeah, 2632.
2632. Yeah.
Because I know it comes out as a fraction, but I didn't like the fraction, so.
Yep, that's fine. So we have 9 grams of aluminum and then excess hydrochloric acid, so who cares about that?
Mm-hmm.
And then it wants to know volume of hydrogen gas produced at standard temperature and pressure.
Mm-hmm.
You can do PivNert, you can do T equals 273, and you can do pressure is 1, or you can know what that means as far as volume, at 22.4.
Mm-hmm.
But you still have to do 9 grams of aluminum, and they want volume of hydrogen gas. You have to be able to go to hydrogen gas. So,
yeah, so 9 grams.
And I'm using definite aluminum is 26.98, but without a calculator, this one's definitely a non-calculator. 27 is going to be good to go with 9.
Oh man.
2 moles of aluminum is 3 moles of hydrogen. And then you can launch into Pivnert now because you have N, T, and P, or you can do 1 mole at STP is 22.4 liters.
Yeah, so it'd be 1/2 because at 3 would come out times 22. It'd be 11, so it'd be 11.2.
All right. This one's a really good one to practice without a calculator because
Yeah.
Sammy's right. You have the 9 and the 3 on the top and the 27 on the bottom.
The 3 smoke out.
And so the question is actually 22 over 2.
Yep.
But if you didn't have this mole-to-mole ratio, then you were probably trying to multiply 9 times 22 and then divide by 27, and it was a giant mess.
Yeah, this one's easier without a calculator. So on 24, I'd make my percent the grams again.
Yeah.
It would be grams, and then we do the same thing. Okay.
Yep.
Can we do 21?
All right, so it wants molar mass again, and it gives you mass, temperature, pressure, and volume. This is the formula.
Where are we on?
Just they didn't give you density.
Yeah, but you can find density.
They gave you mass and volume.
Yeah, you can find it. Isn't that just mass over? So it'd be 3.3 over 2.
So again, this is probably built. If you look at those answers, built when they gave you a calculator, but
times. Oh, I don't like this. 82.
it's 150.
Plus 270.
70. Is that 423?
420. Is it?
All right, so this is probably a calculator question.
Can we try it without calculator real fast? See what we can come up with.
Sure.
Okay, so it's 3. You say to make that 0.1.
The temperature is wrong.
No,
It's wrong.
What?
Is it not?
No, it's 150 plus 273.
Plus 273. Yeah,
It's her.
that's 423.
Yes.
Oh,
Colin.
sorry.
HNO3 is the strongest, right? Or is it HNO4?
There's no such thing as HN4.
Okay.
You win next battle.
I'm burning.
What can burn? Oh, what is that? Where are you?
Oh, I was just trying to do it with what Sammy said.
That's fine.
Okay.
It's like a little more than 1 over a little more than 1. It's 1.
Okay.
250 divided by 5 is 50. Is it D?
Oh. Wow.
Well,
Oh, yes, I did.
calculator.
I got around 50 when I did all that non-calculator.
I did it with the wrong temperature and I still got the right answer. So
You're that good, Becky.
I guess I put it was 100 off and I got a little less than 60. So
All right.
whatever works, I guess.
Yeah. When I did it, I got close to 50. So,
Did anyone do it in the calculator? Is it really 45.8?
I don't know.
I'll do it.
Can you go over 5?
We go over.
Yeah.
Oh, I did not get 45. 38.8, but I probably did it wrong. I got 38.2. I probably did it wrong.
So it should be on your screen, Gabby.
Okay, let's see. It's 1.5. Oh, okay.
Yeah, I crossed out there.
Yeah, that's not bad. Okay, never mind.
Wait, leave it there.
So, my thoughts on this are that I was going to, like, this is all being recorded, and I was going to post this to YouTube.
Wow.
So that if you missed anything early on or you needed it re-explained, you would have access to the entire video.
Oh,
good.
beautiful.
We're gonna be famous.
No.
Well,
On 16, how come it wouldn't be C?
yeah, I thought it was C too.
Okay, so 16 was an actual question and on an AP test or whatever, and I hated this question because I thought it was way unfair. Like, you should be able to tell it's not A or D.
Right.
Yeah.
Cross those out.
But I thought that was way too mean, the difference between 207 and 207.5.
Yeah.
I thought that was
Yeah, that's
crazy.
not fair.
And other than, like, did you guys, you got C and the answer is B?
Correct.
The C. And now it's B.
Yeah, it's B.
Okay, so everyone on board why it's not A
Yeah.
and why it's not, like, it can't be D.
Yeah.
So you have more 208, but then you also have some 204. And these two, I think, combined are going to be bigger than the 208.
Okay.
Like, so, and especially with all three of these are going to be bigger than the 208. So 207.5 says that it would be directly between 207 and 208, like halfway in between.
Mm-hmm.
But these account for more than the 208, so it's got to be a little bit shifted down this way.
Okay.
Other thing is, and I thought this was a terrible question. I really do. I understand your point. It told you lead. This thing was lead, which you can look up on your periodic table.
Wow. That's neat.
And I would go probably with B as the closer thing, but I totally understand. I hated this question. I thought it was stupid.
Okay. So if we get a question like that on the test, should we just look at our periodic table and kind of go off of that?
I would go off of that first. I doubt that they would do that at this point. This was a really old question.
Okay.
But
Dude.
Hey, Miss Irby.
Hello, Richard.
Is it your
Yeah,
birthday
there are
today?
like 4 of us here.
It totally is her birthday. I was waiting for somebody else to say it before I did. Happy birthday, Hurricane.
Thank you.
I didn't say her birthday. I said, is there only 4 of us here?
No, there's a good chunk of people here.
Oh, I don't
if
see
you
her.
Calculus.
we meet
Oh,
all
okay.
night.
There's a dog in one of the videos.
That's us.
Okay, well, turn camera off.
Okay.
Okay, anyways.
Hey, Richard, everything you've missed will be recorded and posted to YouTube, so you can watch the things that you've missed.
Oh, okay. All right. Yeah, I mean, I didn't miss much though, right?
You missed half an hour, so yes.
Right. Okay, all right. Are you guys in 17 now? Okay, cool.
No, we're moving around to whatever they ask.
Okay.
Wait, I can add
Okay, that's fine.
Out of 9, 10, and 11, which have you done? Because I need all 3 of those.
We went over 11.
Done 2 out of the 3 of those.
Okay. Can you do the 1?
10.
Yeah.
Beautiful.
I'm going to go with the answer is A. Is the answer A?
Yeah.
For 10?
Yeah.
No.
Oh.
The answer is not A.
The answer is not A.
The answer is B.
Hurry, I highlighted it.
Is what?
I don't know.
The
Isn't it D?
course site said A.
Hold on. I was pretty sure that we were going to have A on that one. Number is this 10?
Yeah.
10 is A.
Wow.
That's making me doubt myself. Okay. Make sure it said it on the other part too. Yeah. Okay. So that one is minor, but it's telling you like if you had a container of gas and the ideal gas law, we don't account for the size of the actual gas molecules themselves. We say that they're so small that they don't really matter to the whole thing. But the actual gas volume has to take into account the actual size of it. So the size of the gas molecules themselves. So let's see. It's hard to give a real life thing, but if I were going to put you guys in a container, like a stretchable container, and try to calculate the volume off of pressure and temperature or whatever, I would just be ignoring how big you guys are.
Oh.
But in reality, like the idea just says, too small to matter. But in reality, actual gases, some of them are bigger than others, and they actually do account. So like your size would actually take up some space. And that's all that says. It says the ideal gas law does not include a factor for the molecular volume.
Okay.
Not that this is important on the current AP test, but when we actually do go back to the classroom, there's a horrible equation in orange on my back wall that looks like PV equals nRT, but that's been adjusted for real gases, and it has a factor on the volume.
Gotcha.
So,
Can I ask a question that might be dumb?
Go ahead.
Okay, so it says that the ideal gas law does not include a factor for molecular volume. But is that not what V stands for?
Okay, thank you, Emily.
V is for the volume of the whole gas, not the individual molecules themselves.
Oh, okay. That makes sense.
Oh.
Okay.
What, Miss Hergy?
Yes,
You
Thomas.
said do any 20 of the questions we want?
Yes.
Okay.
I mean, you can do all 30, but a completion grade is 20 out of 30.
Okay, because I only did 20. Well, 21. Well, I did 21.
Miss Harry, can you go over number 8, or did you guys already do that?
I can do 8. We did not.
Okay, yeah.
This is a good question for lab stuff because you guys are so good at lab.
Let's do that lab.
So we want to make 2 liters of 0.1 molar KiO3. And how do you do it? Well, you've got to remember that molar is N over V, and they're telling you the V, and they're telling you the big M, but how you actually go make it, you're probably going to have to weigh something out. So we know this is 0.1, and then N and 2. So N is going to be 0.2 moles. We can't weigh out moles, so we have to convert to grams, and they told us the molar mass.
Over 1 mole and 214.
Okay. So you have to be able to do this in your head.
28.
But if you're looking at the options, it's either 42.8 or 21.4. Well, 21.4 would have been 0.1 times 214.
Okay, all right.
And 0.2, then that's double it.
Mm-hmm.
So you get 42.8. So we know our mass is 42.8. So C and E are out. Then the next part is the actual procedure, what you do. So you would weigh out your 42.8 grams, and then we had to do this with our lemonade when we made it last year. So the question is, do you have 42.8 grams and add 2 kilograms of water? Do you do 42 grams of KO3 and add water until the final volume is 2 liters? Or do you do 42.8 grams and add 2 liters of water?
B. Right?
Yeah. You're saying B,
Yeah,
like
B.
So
Yeah, it would be because you add until it fills up to the
right.
until
This
to
is
the top. Okay.
higher than 2 liters.
and then you put the lid on it and you shake it.
Yeah.
Shake it. Shake it.
And if we're making a specific volume, we're not going to measure a grams of water. That's for molality. That's why that was in there. But
Okay.
Richard,
Okay.
sense?
Yeah. So you just fill it up until it gets to the top.
Yep.
So,
Yeah.
okay. All right.
Oh dang, where'd it go?
Wait, Hergy, you said we're doing the thing till 12 to 1, right?
No. For what? What are you talking
For
about?
calculus.
11.
No, that's 1 to 2.
It's 1 to 2?
Yeah.
Okay.
He wants to eat.
Oh, sorry.
Oh yikes.
Somebody
So-
made the dog angry.
I'm just confirming. I think I walked myself through it, but just to make sure that it's correct logic. On 26, is it E because in K2SO4 there's 2 moles of K for every 1 mole of SO4?
Sorry, I'll take the chaos off. We'll just go over that one. So 87 grams K2SO4 dissolved in enough water to make 250 milliliters of solution. Wants to know the molarity. So we're doing moles. So we have to do 87 grams.
Oh.
And then they told us 174 grams. And then you can pick either one to go to. I'm going to do the K plus first. If you did K2SO4, and you can definitely do this different ways, but every 1 mole of K2SO4 is going to make 2 moles of K plus because it's going to split apart with this.
K plus, yeah, and SO4.
So why I did the K plus first is if you were going to do it in your head, 87 times 2 happens to be 174. And so this comes out as 1 mole of K plus. And then you still have to do the volume. So molarity is 1 for K plus, or moles is 1, and then you have to put the volume, but you have to liters. So it's 0.25, which I'm a fraction person. That's 1/4 to me. So I get 4 for the K plus.
Yeah, because you multiply by that, yep.
And then that'll be your answer. And then the only thing different if you did SO4 is this wouldn't be a 1, or that wouldn't be a 2, that would be a 1, because you only make 1 SO4. So you would have exactly half.
Okay.
Should we work a free response, maybe? No?
Yeah.
We're just doing multiple choice first.
Well, we have, but it's been 42 minutes, so.
Oh.
I need help on do problems on number 1.
Same.
Yeah, I need 1 too.
Question number 1? Okay, so keep in mind, if you're going through question number 1, you don't have to get every part on a free response, but you want to know, like, I think you guys should definitely be able to do A.
Oh, yeah, I did A.
And B.
A and
no
B.
problem.
I got lost after CI.
Yeah.
I got lost.
No.
Or like CII.
So wait, does anyone need me to do A or B?
Just do it, just so we can. Okay.
That's fine.
Oh, sorry.
It's fine. So mass percent, that's actually a big deal. Mass percent of carbon, any kind of percent is part over the whole times 100. And so they tell you the part that they want. So we have to find carbon. And since it's mass, we're doing grams of carbon. That's our part. And then we need the whole, and they're going to tell us what the whole thing is. So they told us that the whole was BeC2O4.3H2O.
Yes.
So there's our whole. And they gave us no numbers, which means we got to get everything from the periodic table. So the part that's carbon should be 2 carbons, so 24.02. And then the whole, you've got to add all of these together, but you got to make sure that you know that that's not multiply. That's just attached to. We're just going to add on 3 waters to whatever this is. So the whole thing should be BE, which is, is it 9.8?
151. Oh.
Oh, I was just doing
I just plugged it all to my calculator.
It's 151.078.
Okay. All right. So if you haven't done that, I just want to make sure that when you tack on the water, you guys are right. It's 151.078?
Yes, ma'am.
Mm-hmm.
Okay, so that's the whole. But when you tack on that .3H2O, that means add 3 waters to it. All right, so then you multiply it by 100 and you get a percentage, and this is a relatively small percentage.
It's 15.9.
15.9. Okay, and then on part B, it gives you a reaction. It gives you a grams of this guy. And it's heated to a certain temperature. We're about to get some music.
Yeah, I'm muting it.
But it gives you a grams, and it says how much BeC2O4 can form. So we're just going to go from grams to moles to moles. It's a 1-to-1, and then moles back to grams. Or you can do this percentage that we just did a little bit with BeC2O4 on top instead.
Yeah.
But that's all you're going to do here is grams of that whole thing, and then you do 151.078 grams per 1 mole of it. It's a 1-to-1 mole ratio. And then you would have 1 mole of BeC2O4, and then whatever that weighs.
Oh, I did the
97.03
X over 3.21, and then did a cross multiplication.
You can definitely do a proportion. You said 97.03. Is that what somebody said?
Yeah.
Okay, you would do that over that equals 3.2 or something over 3.
Yeah, that's what I did.
I
got 2.06 grams.
2.06 grams.
I'm hitting all the sick fakes.
And then on the second question, it asks for the volume, and it gives you a temperature and a pressure, and that's kind of like, should be a little alarm that you should be doing.
Pivnert.
Okay, and then, so your problem here is that you're dealing with water, and so they gave you a T and a P. They asked about V, so you have this one, you have this one. They want V. You have to know moles, but you have to know moles of water.
Mm-hmm.
So when you were doing this calculation up above, when I was doing this was BeC2O4. If you wanted moles of water, you would do the same calculation, but you would stop and there would be 3 moles of water there.
Yeah.
And you would stop. You wouldn't go to grams. You would just stop at moles of water and then plug it into Pivnert. You do have a problem with the units on your temperature and your pressure.
You just got to convert it by dividing by 760.
Right. You got to
Did you say it was the same thing?
And add 273 to your temperature. Okay. But C, I did want to spend our remaining time on C because I think that that's a really good, that's more like what they're going to ask nowadays.
Okay.
But if you could do A and B, I think there were, I don't know if I gave you guys the points, but there were at least 4 points sitting on A and B out of the 10.
Okay.
So.
Miss Hergy.
Yes.
I also need help on 3B, 2I, and 3I.
Thanks, Colin.
No, I'm just like, are we gonna have enough time to talk about them?
We'll do that at the end. We'll go to that one. We'll go to the end. Okay. So C, I do want to make sure you understand C because it kind of turns a corner. You guys know what anhydrous means?
No water.
No water. So it's turning a corner a little bit. It's saying, hey, we don't have the 3H2Os attached anymore. It's just this guy. But it gives you a sample of anhydrous BeC2O4 contains an inert impurity.
Mm-hmm.
It's saying this 0.345 grams is BeC2O4 plus some stuff.
Crap.
Okay, so you can't use that 0.345 as just the grams of BeC2O4. That's going to end up being a whole. Like, if you look down at what 4 asks, it asks you to calculate the mass percent of BeC2O4 in the impure sample. That's the whole.
Okay.
So that's what that was for. And part of this is you're going to go figure out how much BEC204 is actually in this.
Okay.
All right. So it says it was dissolved in sufficient water to produce 100 milliliters of solution. And then a 20 milliliter portion of the solution was titrated with KMNO4. And that just means we're gonna do a reaction between the two and you're going to control it.
Yeah.
So we're only taking a fifth of the whole solution here. Just a tiny portion. Give you a balanced equation. It says the volume of 0.015 molar KMNO4 required to reach the equivalence point was 17.8 milliliters. So when you see that equivalence point, there's a formula that goes with this.
And 1v1 equals M2v2.
Right, but there's an issue with this that when we did this with acids and bases, we had to do the mole to mole ratio, had to go in there. And that's what makes this problem tricky. But equivalence point literally means moles of the MnO4 or the KMnO4 is going to match the moles of your BEC204. That's what equivalence means. It literally means that they're equal. But they're giving you a molarity and a volume, which is supposed to be a hint that you're going to do a molarity times volume situation. That's how you find the moles. I wouldn't worry about the way they asked it, but they could ask it in using different language and the same thing. The reducing agent is the thing that got oxidized. So if they said identify who was oxidized in this reaction, oxidized means charge goes up.
Goes up. Leo.
Yeah, we said carbon.
Loss of election.
Loss of electrons is you're gonna get more positive because you're gonna lose negatives. So you have to figure out whose charge went up. So just to remind you, it's been a while since we've done this. H right here is a +1. O is a -2.
O is a -2.
So that makes -8 because there are 4 of them. And we have to end up at a -1. So Mn has to be a +7.
Yeah.
In the second part, and I'm ignoring these coefficients out front because they don't change the charge. They're important when they relate, but they don't change the charges. In the C2O4, O is a -2. That makes a -8. We have to end up at a -2. So carbon has to account for a +6, but there are 2 of them.
Yeah, so take 3.
+3.
So each carbon has to be a 3.
Oh.
Okay, and then on the other side, Mn is a +2 all by itself. In carbon dioxide, O is a -2. Carbon's a +4.
+4.
Hydrogen's a +1, and oxygen's a -2. So if you haven't done that in a while, if you go back and watch it, take the time to go, okay, did I understand where all those charges came from?
So is carbon.
So who was oxidized, whose charge went up?
Carbon.
Was carbon's. So we're going to put it as that whole blob because it was part of that, but that was the actual thing that got oxidized. The element was carbon.
Okay, so but the answer is C2O4 2 negative.
Yes.
Okay.
Because you can't separate the carbon from the ion right there. Okay, so for the second part, even if you can only do one part of this, it's okay. It says for the titration at the equivalence point, calculate the number of moles of each of the following that reacted. Well, the first thing is MnO4 negative, and they gave you stuff about KMnO4. They gave you the molarity and the volume. Whoa.
That was my brother.
Yeah.
Yeah.
Okay, so they give you the molarity and the volume. You do have to make sure that your volume is in liters because you're looking for moles. So you're essentially plugging into this formula, but you're going to get M times V to solve for moles, which is what that M1V1 is.
Liters. And C2.
I got lost.
Where?
Wait, okay, so we have the molarity. How did we... Oh, never mind. No longer lost.
Oh.
I couldn't figure out how to find the moles of C2O4 -2.
Okay, that's what we're about to do. So I want to make sure everyone's okay with finding the moles of MnO4 negative.
Did you just use M equals N over V? That's all you did, right?
I just ended up multiplying my V and my M to find my N.
Okay.
But you do have to make sure this is the right volume. Make sure that you divide by 1,000. Move that decimal place 3 places. Okay, and the other thing is, this is kind of like a lab situation. Sig figs, you need to like not round to 1 because you're going to round away your percentage in the end. So I've been keeping 3. Okay, so then hopefully everyone's okay with multiplying those two things and getting 2.67 times 10 to the negative 4th.
Yeah.
So in all of our acid-base stuff, we just set these two equal to each other because the mole-to-mole ratio between acids and bases is always going to be a 1-to-1 for us when we do our equilibrium stuff. But this is a 1-to-1. So what you had to do, since they only gave you amounts of the KMnO4 to reach equivalence, if you know amounts of MnO4 negative, you can do the mole-to-mole ratio to figure out how much C2O4 actually reacted. So we would do 2 moles of MnO4 negative is 5 moles of C2O4 negative.
Oh,
okay. From the mole-to-mole ratio. So if you know how much MnO4 reacted, you can the mole-to-mole ratio works to figure out how much of the other one reacted.
C2O4.
Wait.
Oh, you already did it. 6.6.
Hopefully I did that right. I'm doing it on my phone calculator, so make sure that I'm not screwing this up.
You don't have a scientific calculator with you?
Dude, it's in my backpack. I have to lean down and turn it on.
Oh my goodness.
Me.
You guys okay with that part?
Yeah.
I guess.
Well, tell me if you're not.
No, I had it. I was just waiting for 3 and 4.
I didn't know it was that easy.
Yeah, that one's really easy. It just
So, like, equivalence just literally means the two things are going to be in equivalent ratios. It's just that if it's not a 1-to-1, you're going to have to use the mole-to-mole. And that's what we did with our, if you remember back when I first taught you titration stuff, we did moles of OH negative and H plus, and I kind of said I was shortcutting it and putting those in there for you. This is how much is in 20 milliliters.
Right. Oh, multiply that by.
They want to know how much is in the 100 milliliters.
Oh.
Did you do a proportion?
Yes. So if 6.68 times 10 to the negative 4th is per 20 milliliters, then how many are per 100 milliliters? Cross multiplying, and it would be the same thing as multiplying by 5.
Which is.
Okay, how do I do this in my calculator? I'm using a different calculator. Oh, I found my graphing calculator.
Yay!
I thought I left mine in Rush Springs because I couldn't find it in my backpack, but I got it.
Is it 3.34 times 10 to the negative 4th? You mean 3rd?
Yeah, I should 2 to the 4th.
Can you see if this is how I'm supposed to put it? I'm going to put my calculator. I need you to tell me if this is how I put in the calculator. How do you put the camera?
Hold on, I'm looking at Sammy's calculator, but I just see Sammy's bun.
I'm trying to fix it. Okay. Is that right?
No, I don't think so. Did you type in the little, like the time symbol? Oh, sorry. Do you not have the E button?
Is that it?
E button right above the, no. Right above your comma. There's an EE.
Oh, right here?
Yeah.
That's it?
So do 6.68 shift comma.
Oh my gosh. 8 shift.
Or second, comma. And I'll put a little E.
To the negative 4th.
And then you do negative 4th. Yep.
Okay, thank you.
All right, and then, so you guys got that for 3?
Uh-huh.
Okay, and then it wants to know the mass percent of BeC2O4 that was in the 0.345. So part over the whole times 100, but we got to do grams. So we know the whole is 0.345. we need grams of BeC2O4. So this one's just a little bit of stoichiometry. We know that there were 3.34 times 10 to the negative third moles of C2O4 2 negative in the 100 milliliter sample. And then you don't have to show this if you understand it, but for every 1 mole of C2O4 2 negative, there's 1 mole of BeC2O4. Because you get exactly one of these C2O4s out of one BeC2O4. And then you have to do 1 mole of BeC2O4. And then the molar mass of this, which I think you guys said was 97.03. I think.
Yeah.
And this gives you 0.324 grams of the BeC2O4. Which is what you put here.
Wait, where?
On the top.
Oh, over there.
Over the roll.
Okay.
You get 93.
Wait, is that that's the answer 0.324 to that calculation?
Yep.
Okay.
Oh, no.
Oh, okay. So then that's the answer for 4.
Yes.
Okay.
Yeah, but they love this question about mass percent and impure things because that's actually a really good lab thing is to try to pull good things out of a bunch of garbage. So you need to be aware of mass percent. All right, and then Colin, you said 3?
3B 2 and B3 last 2.
Wait. Before we do that, can you explain in C4? Can you explain the multimole ratio?
If you have BeC2O4 and you dissolve it in water, this is how it would split apart.
Okay.
So for every one of these that you have, you had one of these.
Oh.
It's just like, but from the formula, kind of like where you did K2SO4.
Yeah.
That it had to split up, and you had to have 2 Ks in one K2SO4.
Okay.
You can tell that from the formula. You didn't have to write this whole reaction. You could have told that, right?
Yeah.
You kind of tell that from the formula of BeC2O4 that there's one C2O4 in that formula.
All right. Brilliant.
Brilliant. All right. And then 3B, 2, and 3, which you have to be able to do A to be able to do this. So A is, I'm pretty sure your favorite.
Limiting reactant.
But it's easy, super easy. Okay, so I'll let people actually look at it. So you got 0.6 moles of barium nitrate and 0.3 moles of phosphoric acid are combined with a final volume of 2 liters. And here's the reaction, and you have to figure out the mass of Ba3PO42 that was formed, and only one of those numbers is useful. One's limiting and one's excess, and so you have to pick one. So if I pick the 0.6 BaNO32 and convert it to the units of the other one, I would do 3 moles of BaNO32 is 2 moles of H3PO4. And that would give me 0.4 moles of H3PO4. That would be how much I needed. I don't have that much. So this guy must be limiting. And barium nitrate must be excess. So whatever I do, all of my answers should be based off of my limiting reactant. Okay, so I'm going to erase that work right now. I can do the next part.
Bye, Hergy. Thank you.
Bye. Okay, so with the 0.3 moles of H3PO4, if I were answering the first question, I would do 2 moles of H3PO4 makes 1 mole of barium phosphate. And then Colin, what's the molar mass?
601.93 over 1 mole.
1.93?
Yes.
All right, and you get some grams. That would be relatively large.
90.3 grams.
Okay, and so the 2 and 3 are, well, 3 is actually easy, but it's a hard concept to understand, I guess. 2 is a little bit harder. So with 2, the pH of the resulting solution, pH is going to come from acidic or basic solutions. So barium nitrate is a salt that both things came from strong. That's nothing to do with pH. This guy's a weak acid. This guy is a salt again, and it's a solid. It's not going to contribute to pH. And this is a strong acid. So we've got 2 possible acids in there, and we have to be able to figure out the pH.
You'd use the strong acid because the weak acid wouldn't do much to the pH in general.
Correct. And also, with this reaction being with H3PO4 being limiting, at the end of the reaction, there is none of this left over.
Oh.
So you only have this left over that's going to contribute to anything with pH. And so instead of going to BA3PO42, I'm going to say, okay, H3PO4, it's going to make 6 moles of HNO3. And then would be, what, 0.9?
Yes.
Moles of HNO3?
Yes.
Well, pH we need, if we're doing a strong acid, negative log of concentration of H+, this has to be molarity. So you're going to have to take your moles, and you're going to find molarity, and that's why they told you that you had 2 liters.
Oh, okay.
So if you divide this by 2 liters, you get 0.45 molar.
Yes.
And so then to find the pH, all you have to do is negative log of the 0.45.
I got something weird.
It should be very, very low.
0.34.
Okay. It's a strong acid. Nitric acid's pretty nasty.
Okay, I thought I did it wrong. I didn't know what I was doing. Okay.
Did you not check the answers?
I was doing it last minute, so I was trying to keep up with you and finish it in time.
Yeah.
So is everyone know the answers are on course sites?
Yes.
Everything? Okay, and then the last part is a harder concept, I guess. Okay, so hopefully you're okay with this and you can go back and watch what I did there and pause it a little bit, because I'll make sure people can go, and I got to get some stuff done before I do calc again. But the third question asks, so what's the concentration in moles per liter of the nitrate ion after the reaction reaches completion?
Wouldn't it be the same thing to H plus because they both split up at the same time and there's a 1-to-1 ratio?
Not quite.
Yeah, so this is the one where
There's going to be the same amount of NO3. There's going to be some from over here, but this guy was in excess, and you're still going to have this stuff floating around. So there's 2 ways to do this. There's a really complex way to do this, and then there's an easy way to do this. So the complex way is to figure out how much HNO3 you have, and then convert that to how much NO3 you have, and then figure out how much excess of this you have, how much is left over, and then add the 2 together. Doing this is to understand that nitrate is always soluble in whatever form it comes in. So in the beginning, when you had barium nitrate, it existed like this. And then when you pour them all together, you're going to have the HNO3 separate, and you're still going to have some leftover BaNO3. But the NO3 that you started with, the total amount is not going to change because it's still going to be soluble. So whatever NO3 you started with over here, some of it changes to this and some of it stays as this, and then you would add the 2 together, but it's not going to be any different from the original amount of nitrate, because nitrate didn't change into a solid or anything. Nitrate's a spectator the entire time, so it's just going to sit there. So if you figured out, if you said, hey, I had 0.6 moles of barium nitrate to start with, and for every 1 mole of barium nitrate, there are 2 moles of nitrate. That gives me 1.2 moles of nitrate total. Like in the at all brought to the reaction altogether is 1.2 moles of nitrate. So no matter whatever we do, it's a spectator. It's just going to sit there. It wants to know what's the concentration in moles per liter. You have 2 liters.
Oh, that's it.
That's the easiest way to do it. Instead of going figuring out how much is left over as barium nitrate, how much is nitric acid. Nitrate was a spectator.
And you got the 2 because of the subscript that NO3 has on the bottom of it.
Correct.
Okay. So...
Hey, we have to go, but we love you all.
This video will be posted on my channel if you wanted to go back through and watch anything.
Okay, cool. Thanks.
All right.
Bye.
All right. All right. Anybody else?
Yeah, I'm sorry. I was gonna say, like, when I was trying to do 3B, like, I was able to recognize 3A was Lewis reaction. But then, like, when I got to 3B, I just got, lost.
That's okay. That's a tough one. You don't have to get 10 out of 10.
Oh yeah. But I was able to get 3A though, so
good.
1 out of 10 would not recommend.
Bye, Hergy. Happy birthday.
Happy
Bye. Thank you.
Okay.
I'll try to do more multiple choice and free response when I have time, since I've been trying to keep up with everything, Miss Hergy. But I did the minimum that you wanted, at least.
Excellent. All right, I gotta go get some stuff done in between this, and I've got another calculus thing this afternoon. So
I just have a few questions on calculus.
Well, okay, yeah, I'll just watch the video. You said it's gonna be on Google Classroom?
No, it's gonna be on YouTube.
Okay, oh, your YouTube channel? Yeah, the one.
Go to my YouTube. I'm not trying to list it or anything. I don't want it public, but I think if you go to my YouTube channel, if you just look like Catherine Hergenrather, you should be able to see it.
Okay,
and
yeah.
Tell me if you can't.
Okay, I mean, I watched one of your linear graph videos, so.
I know they're super exciting, aren't they?
Yeah, I mean, like, back in.
Okay.
All right.
Okay.
All right, guys.
Bye, Hergy.
Bye. Bye, Luke.
Bye, Luke.
Okay, bye, Mr. Hergy. I'll just watch the video because I think I might have missed the beginning.
You did.
Oh yeah, I.
Do you not? Are you not on
Remind? Yeah, I'm confident that I missed the beginning.
Are you not on Remind, Richard?
No, I am. It's just that when I clicked on the Remind link, it wouldn't work because I don't have the app. I have it through my messaging app. I didn't go as far as downloading the app.
So you're on your laptop then, right?
No, right now I'm on my laptop. Yeah, but like when I clicked on the link that you sent me on Remind, it wouldn't work because I don't have the Remind app. I have the Remind through my messaging app.
Oh, okay.
So.
All right. Well, okay. I just want to make sure you were getting my messages. So.
Oh yeah, I do.
Okay. All right. Well, I'll post this video.
Okay.
Tell me if you have any questions.
All right. Okay. Bye.
Bye.